All right, so this is straight up quadratics practice. So there's nothing on here that you haven't learned before. We're just going to go through it. Make sure that you feel confident. If you need a little extra help, this is a good place to get it. All right, so these, let's say 4, are solve for x in each equation. Okay, so when you're solving a quadratic, which all of these are, how do I know this is a quadratic? Because there's a square, a square, a square, a square. So when solving a quadratic, the first thing you ask yourself is, can I solve by square rooting? Okay, let's look at all of them and see if you can solve by square rooting. If there's an x squared and an x, you cannot solve it by square rooting. Okay, so let's go through. A has just an x squared, so you can solve by square rooting. So I'm going to put SR for square rooting. This has an x squared and an x, so that's a nope, can't. This has just an x squared. It doesn't have an x squared and an x. So if you're like, it has an x and an x squared, there's not an x squared and an x. That's what I'm looking for, like B does. So this you can solve by square rooting. This has an x squared and an x, so that is not solvable by square rooting. Okay, so let's solve the two that are solvable by square rooting. The first one, in order to solve it by square rooting, you have to get x squared by itself. The first step to getting x squared by itself is add 16 to both sides. So now I have x squared is equal to 16. And now I can get x by itself by square rooting. Remember, when you square root, you have to account for the positive and negative number that when you square it, you get that value. So I have x equals positive or negative. The square root of 16 is 4. Now the directions, I'm assuming, also say something about rounding. No, they don't have them. But if we do have to round, we will round to the nearest hundredth, and I believe that's what the directions will say on the test also. But this might not need any rounding. That's might not why I have it. That might be why I don't have it, but who knows? We'll see. Okay, next one. Oops, let's do the square rooting, we said. Okay, so I want to solve this one by square rooting also, but if you look at what the square is on, I'm going to erase everything I highlighted. The square is on the x minus 5. So I have to get the x minus 5 quantity squared by itself so that I can square root. So step number 1 is to add 27 to both sides. I have 3 times x minus 5 quantity squared equals 27. X minus 5 quantity squared is still not by itself, so now I have to divide both sides by 3, divide by 3, divide by 3. So now I have x minus 5 quantity squared is equal to 9. And now I can square root to get rid of that square. So I'm going to do square root plus or minus. Square root plus or minus. So on the left side I have x minus 5 equals plus or minus. And we do know the square root of 9. The square root of 9 is 3. Next I have to add 5 to both sides to get x by itself. And I have x equals 5 plus or minus 3. So now I'm going to get my two answers. I'm going to do 5 plus 3, which is 8, and 5 minus 3, which is 2. So I have two answers, 8 and 2. All right, so when there is an x squared and an x, like in these two, you cannot solve by square rooting. So what we're going to do if we cannot solve by square rooting is we're going to ask ourselves, can we factor it? Okay, so let's make a list at the top right here since this is our practice. 1, see if you can solve it by square rooting. Wow, R-E, square rooting. Okay, you can't have an x squared and an x in order to do that. Number 2, if you can't solve it by square rooting, you're going to check to see if you can factor it. Remember, you look for a GCF first. Then use, I'm going to do this right here. You should know what that means. That's where you do A times C, B, and then you get your two numbers. Okay? Now, if it's not factorable, you go on to the last resort, which is quadratic formula. Quadratic formula is the last resort. You only use it if you have to. Okay, so let's see. We already said it's not solvable by square rooting, so now I'm going to look for a GCF. Is there a GCF in these three terms? Oh, it has to be equal to 0 first in order to factor. And it already is. Is there a GCF? No. So now I'm going to make my little organizational X here. I'm going to say I'm looking for two numbers that multiply to give me. A is 1, B is negative 2, C is negative 15. A times C is negative 15, and then B is negative 2. So two numbers that multiply to give me negative 15, and when I add them, I get 2. 5 times 3 is 15, and I can make the difference 2. It has to be a negative 2, so I'm going to make the 5 negative. Divide both of those by A, and so I have the factor of x minus 5 and x plus 3, and then don't forget your equals 0. Now you can set each factor, there's two factors, x minus 5 and x plus 3. You can set each factor equal to 0 and solve. So you get two solutions. X equals 5, x equals negative 3. All right, let's move on to the last one. Let's pretend like we don't know what to do and go back to our list here. Can I solve by square rooting? No, there's an x squared and an x. Can I factor it? So let's look for a GCF. Do these three things have anything? Oh, it's already equal to 0. I forgot to mention that. It has to be equal to 0 to check to see if it's factorable. There is no GCF. So now I'm going to move on to my little x here. This is A, B is 1, C is negative 2. A times C is negative 20, and B is 1. So I'm looking for two numbers that when I multiply those two numbers, I get negative 20. And when I add those two numbers, I get 1. I do know two numbers, 5 and negative 4. Now please make sure you divide by A, which is 10. Both of those fractions are simplifiable. 5 goes into both the numerator and denominator once, twice. So this is your 2x plus 1. And now for my other fraction, let me zoom in again here. 2 goes into both the numerator and the denominator. So it goes in there negative 2 times, and it goes in there 5 times. So this is a 5x minus 2. Don't forget the equals 0. Now you have your two factors, and you can set each factor equal to 0 and solve. 2x plus 1 equals 0. 5x minus 2 equals 0. This one we're going to subtract 1 from both sides. You have 2x equals negative 1. Divide by 2, and you have x equals negative 1/2. This one, add 2 to both sides. 5x equals 2. Divide by 5, divide by 5. X equals 2/5. And there's my two answers. Will you always get two answers? No. We have two, these are two x values, which are your two x values of your x-intercepts, right? Which is leading into what we're doing next. So you could have no solutions if it doesn't touch your x-axis, or one solution if it only touches it once. All right, here it says, given the graph to the right, match each equation to the color it is drawn in. Okay, so I want to know which one's which. So first off, I see two downward-facing parabolas and two upward-facing parabolas. And I know this is downward-facing. This is downward-facing. This is upward-facing, and this is upward-facing. So at least I have it ruled down to a 50-50 shot. All right, what I'm going to do is I'm going to use my x-intercepts for help. Okay? If I solve this, I get x equals negative 4 and if this was equal to 0 and I solved it, I would get x equals negative 4 and x equals negative 1. That means I have x-intercepts of negative 4, 0 and negative 1, 0, and it's facing upward. Those are things I know about this one here. So that's what I'm going to look for. Negative 4, 0 is here. Negative 1, 0 is here. And the graph that's facing upward is my red one. So this is red. Here, same points, right? Because it's the same stuff here. So I'm going to hit copy, paste, boom. Right? You have x if you set it equal to 0 and solve, you get negative 4, 0 and negative 4, 0, negative 1, 0. But this is downward facing, so this is going to be blue. Now I know by process of elimination you can figure out which one's which on the last two, but let's actually do this. So if I made it equal to 0, I get x equals 4 and x equals 1. So I have x-intercepts of 4, 0 and 1, 0. Same thing on the second one. Hit copy, paste. but one's up and one's down, right? So that's how I know that that's right. So here's 1, 0, and 4, 0. Oops. 1, 0, and 4, 0. The one that's facing up, the green one. And this is yellow or orange, whatever color you think it is. I can't really tell. I think it's gold. Okay, last but not least, we have graphing. Okay, so it says graph each equation and find all the key information. So first off, you have to know what form it is in. So if we go through these, A is in standard form. This is just plus 0 for your C value. B is in standard form. It's just that there's no B value. Okay. C is in vertex form. D is in standard form. So that's helpful to know because then you know what to do, right? So we'll do this one first. We're going to say standard form. Okay. So if it's in standard form, what I want to do is I want to factor it in order to get it into intercept form because then I'll know what to do. All right, so first thing I ask myself is there a GCF? There is, X. So that's X minus 4. I'm going to get rid of what I highlighted there. Okay, so now I'm going to find my X-intercepts by setting it equal to 0 and solving. So I have it 0 equals X times X minus 4. Set each factor equal to 0 and solve, and I get X equals 0 and X equals 4. So please make sure you write intercepts as points. I got 0 for X when I plugged in 0 for Y. I got 4 for X when I plugged in 0 for Y. So I have 0, 0, and 4, 0. Now I need my vertex. If you look, the number directly in between these two is 2. So I know it's 2 comma something because it has to be symmetric and your vertex is right in the middle. Now I need the Y value, so I'm going to do Y equals, and then I like to do 2 sets of parentheses because I'm going to plug it in here and here. If I plug in 2 in the first X, I just get 2. The second one, I get negative 2. 2 times negative 2 is negative 4. So I have 2, negative 4. Now for my Y-intercept, I'm going to plug in 0 for X and see what I get for Y. Or I can realize that, remember, if it's in standard form, it's just the C value, and the C value is 0 here. Or I know if 0, 0 is an X-intercept, it's also a Y-intercept. So now I can connect these and make my parabola. And there it is. All right, let's try another one here. So first off, I need my X-intercepts. All right, so I need to factor it in order to do that. So I look for a GCF first, and I say, okay, there is no GCF. So then I say, all right, well, I'm going to use my X for organizational information here. I need to know what A is.
I'm not sure I understand.
I need to know what A is. So A is right here. It's 1. B is in front of X, and there is no B. So B is 0. I can throw that down right there. C is negative 4. A times C is negative 4. So I need 2 numbers that multiply to give me negative 4 and add to give me 0. 2 and negative 2. Divide by A, which is 1. So this factors 2. Y equals X plus 2 times X minus 2. Now I chose these two because if you look at them, they look very similar. In fact, if I go like this to that one, they're exactly the same, right? But one has an X on the floor, one doesn't. One has a GCF. The other one, you have to use the X method to factor it. Okay, so now I'm ready to find my X-intercepts. To find my X-intercepts, I'm going to set Y equal to 0 and solve. So I'm going to do 0 equals X plus 2 times X minus 2. So I get X equals negative 2 and X equals positive 2. So I have 2 X-intercepts, negative 2, 0, and positive 2, 0. Negative 2, 0, and positive 2, 0. So if you look at what's right in the middle, that is 0. So I know the X value of my vertex is 0. Comma, and now I need the Y value. So I'm going to do Y equals. I'm plugging into 2 places. So I'm plugging in 0 here and here. 0 plus 2 is 2. 0 minus 2 is negative 2. 2 times negative 2 is negative 4. 0, negative 4. My Y-intercept, when I plug in 0 for X, what do I get for Y? Or you know it's 0, comma, C. C is negative 4, so 0, negative 4. And obviously your vertex is your Y-intercept. Not obviously, but you can see now. So you don't have to do the work again. And there's that parabola. All right, let's move on to C. So C, I notice, is not in standard form. It's in vertex form. So I can immediately see my vertex. Remember, it's the opposite of this and then this. So my vertex is 4, 9. Write that down right away. 4, 9. 4, 9. Boom. Right there. Okay. Right there. All right. Now I need my x-intercepts. So x-intercepts, set y equal to 0 and solve, right? This I have to just immediately, it's not in standard form, so I can't factor it. I just need to solve this. So I'm going to write it out where it's equal to 0. Okay, now I need to solve this. Remember, since there's not an x squared and an x, you're not going to solve by factoring. You are going to solve by square rooting, but you have to get that alone first. So I'm going to start by subtracting 9 from both sides. I have negative 9 is equal to negative x minus 4 quantity squared. Still want to square root, but I can't yet because it's not by itself. Please realize this is a negative 1 right here. So divide both sides by negative 1. And I have 9 equals x minus 4 quantity squared. Now I can get rid of that square by square rooting. Don't forget plus or minus. So I have positive and negative 3 is equal to x minus 4. And then I can add 4 to both sides. So I have x equals 4 plus and minus 3. 4 plus 3 is 7. 4 minus 3 is 1. So I have two x-intercepts, 7, 0, and 1, 0. 7, 0, and 1, 0. And if you look, it's looking very symmetric. Still need my y-intercept, so I'm going to plug in 0 for x and see what I get for y. Now remember, it's not 9. Okay, it would make no sense for it to be right here because people will say like, oh, it's C. That's not C. It's not in standard form. Okay, so we have to plug in 0 for x to see what we get for y. So we have y equals the negative, and then I have to plug in 0 for x and then square it, and then I have to add 9. Okay, so if I plug in 0 for x, I get 0 right here I'm talking about. 0 minus 4 is negative 4. All right, now I need to clean this up. Negative 4 squared is 16. So now I have negative 16, because of this negative right here, plus 9, which is negative 7. So I have 0, negative 7, right there. If I want to make the symmetric point, I can. It's right there. All right, I'm just looking at the pattern that's being followed, and then I can make my downward facing parabola. There we go. All right, the very last one. So it is in standard form, Okay, so I need to factor it. First thing I do is I look for a GCF. Those three terms do not have anything in common. So I'm going to make my little organizational X. A is 1, B is negative 6, C is 8. A times C is 8, B is negative 6. Two numbers that multiply to give me 8 and add to give me negative 6. Two numbers that multiply to give me 8 and add to give me negative 6. So 4 times 2 is 8, but that doesn't give me negative 6. But negative 4 times negative 2 is also 8, which adds to give me negative 6. That works. Divide by A, which is 1. And we have y equals x minus 4 times x minus 2. Now I can find my x-intercepts by setting y equal to 0 and solving. So I have x equals 4 and x equals 2. So my x-intercepts are 4, 0 and 2, 0. 2, 0, 4, 0. Right in between is 3. Now also I want to remind you is that if you didn't have graph paper and you were just, filling this information in, you could do this plus this. The two x's added up is 6, and then divide it by 2, and that'll give you the 3 also. That's how you find the middle. Oops. Okay, now I need my y value, so I'm going to do y equals, and then I like to do my 2 sets of parentheses that I plug it into. So I'm plugging it in here and here. I'm plugging in 3. 3 minus 4 is negative 1. 3 minus 2 is 1. Negative 1 times 1 is negative 1. So 3, negative 1. Y-intercept, 0, comma. And then this is in standard form. I can see C is 8. So 0, 8. I made this symmetric point right there, and then you can go ahead and connect your points to make your parabola. Now, I look at this, and do you see how it's kind of weirdly shaped? So what I realize is that that point that I made right here, it's not in the right spot. So here's how I fix it. And did I do it on purpose? Absolutely not. So if you look, this point right here that I know is at 0.8, from this point right here, it's 2 over, right? And I only went from this point right here, I only went 1 over. So I need to move that over 1. So I go, oh, 1, 2, right there. That's where it's supposed to be. Now when I connect these points here, you'll see that it's much better looking. And there's that parabola, much better looking. Okay, that's it for the practice. And once again, nothing new in here. It's just a nice